right, hello everybody. I wanted to do a problem with a point of intersection between some planes here, and this should feel a lot like what we did back in Algebra 1 when you are finding the point of intersection of lines. And when you have these plane equations like in problem 5, it should feel like elimination is what you're doing. When you go on and take linear algebra later, you'll do it with a matrix, and you should just really realize that the matrix row reduction algorithms are just the same as the elimination method. So I'm going to start with plane number 1 and plane number 3, and the reason I'm going to start with those is because they have the same number of x's. So if I take plane number 3, x plus 2y minus 3z equals negative 4, and I write underneath that plane number 1, x plus y minus z equals 1, and I subtract those two wonderful planes, I get y minus, 2z, if I didn't mess up my negatives. So y minus 2z equals negative 5. Great. And then that gives me a substitution that I can use later if I want to use that. I'm going to use the plane equation number 1 again, and I'm going to use plane equation number 2. And so I'm actually going to double my plane equation number 1. So I'll have 2x plus 2y minus 2z equals 2. So this is plane number 1 times 2. And then here's plane number 2. 2x minus 3y minus 9z equals 10. And I'm going to subtract those again. And the reason I'm subtracting the x values again is if I can eliminate the x values twice, then the substitution I just found on the left side of the screen is a lot more useful. So, 2x minus 2x cancels out. 2y minus negative 3y makes 5y. And then over here, negative 2z minus negative 9z becomes plus 7z. Yes. And 2 minus 10 is negative 8. Great. So now I have two equations in two unknowns. And so now it should feel pretty familiar. I'm going to go back over here to the left side, say y equals positive 2z minus 5. I'm going to bring that back over here to the right side of the equation, 5 times y. So 5 times 2z minus 5 plus, 7z equals negative 8. Multiply the 5, 10z minus 25 plus 7z equals negative 8. Combine my like terms, so I have 17z. Add 25, so I have 17. It's so nice when the numbers work out and you get z equals 1. Hooray! Take your z equals 1, go back over to your substitution. Y equals 2 times z minus 5, which results in y equals negative 3. Wonderful. Now I have two values, and I can use whatever plane equation makes me happy to find the missing third value. So z equals 1, y equals negative 3. I'm going to use plane equation number 1 again. X plus y minus z equals 1, leaving me with x is equal to 5. Double check your work like a good little math student. We know it works with plane equation number 1. 5 minus 3 minus 1 makes 1. Let's just double check it with the second one. Does 2 times 5 minus 3 times negative 3 minus 9 times 1, does that equal 10? I believe so. That's 10 plus 9 minus 9. Check. Last thing to check is plane equation number 3. So we will write 5 plus 2 times negative 3 minus 3 times 1. Does that equal negative 4? And I think it does. That's 5 minus 6 minus 3 equals negative 4. So we found the only XYZ point that is a solution to all three plane equations. And so we can celebrate, and we know the point of intersection is 5, -3, and 1. We can put a happy little bubble around it, and we're done.